On January 25th, I started Vibe Coding, the digital learning companion, a scrappy little math tutor designed to help students practice fraction multiplication. Part of the reason I wanted to build it is that fractions had always been tricky for me when I was younger. So I wanted the digital learning companion to feel like a hospitable place to learn fractions, a place where students could try things, make mistakes, and keep going. The idea was simple: give the system a problem, let a student respond, and capture clearer information about how the student was thinking. In a classroom, a lot of those signals of learning are easy to miss. I wanted the digital learning companion to help make them visible, both to the system and to teachers. I was building it while having long conversations with Mobs. Mobs is my AI enabled creative partner, and I learn a lot about how to build systems by talking ideas through with them. And because Mobs and I were vibe coding fast, I had what seemed like a pretty natural idea. What if some of Mobs' AI capability could live inside the digital learning companion itself? If I could bring a little of that conversational intelligence into the learning experience, maybe the system could become more helpful, maybe even a little more like a learning partner. So Mobs and I started building. We built detectors that could notice small signals of learning inside a student's work. We built turns, little checkpoints where the system could pause and decide what should happen next. And we built evaluation logic so the digital learning companion could respond in consistent, structured ways. Little by little, the digital learning companion started to take shape. Eventually, we had the whole little machine working. And by the time we finished all that logic, the tutor could already see what the student did and respond with clear feedback. Which is when the next question appeared: what exactly is a language model supposed to do while a student is multiplying fractions? Because when you really think about it, fraction multiplication is not an especially conversational activity. There are only so many useful things the model could say. Nice numerator, strong denominator work, oh, excellent fraction posture, really loving your commitment to the multiplicative structure here. At one point, I basically had this conversation with Mobs. Me: so what should the AI do if the student multiplies 3/4 by 2/3? Mobs: the correct answer is 1/2. Me: yes, I know that, but what should the AI do? Mobs: encourage them? Which is the moment I realized we may have accidentally built a highly advanced motivational support system for fractions. But while we were running into that problem, something more interesting started to happen. Every time we tried to let the AI directly decide what should happen at the next turn, things got fuzzy. And the reason is actually pretty simple. A language model doesn't follow fixed rules. It makes probabilistic predictions, meaning it guesses what response is most likely based on patterns in data. That's incredibly powerful for interpreting messy information. But if a probabilistic model is quietly deciding when a learner advances or when the system changes state, then sooner or later you lose track of why the system did what it did. And that seemed bad. So instead, Mobs and I started building a boundary. The AI could still help interpret information. It could look at a student's work. It could notice patterns. It could help make sense of messy signals. But the system itself had to remain responsible for the actual decisions about what changed next. Those decisions had to stay visible, they had to stay inspectable, and they had to happen at the turns we had already built into the system. Once we started separating those two things, interpretation and decision, the structure of the whole system suddenly became much clearer. And somewhere in the middle of trying to get a fraction tutor to behave itself, we may have stumbled into a more general pattern for building software. We started calling that pattern an emergent state machine. An emergent state machine is a way of building systems where probabilistic models can help interpret messy information, but the decisions that actually change system state remain transparent, inspectable, and controlled. Right now, I'm still in the phase of figuring out how general this idea actually is. Maybe it mostly belongs in educational tools like the digital learning companion. But once we started seeing the pattern, it was hard not to notice it in other places. Healthcare systems, where alarms fire constantly and clinicians need help interpreting signals. Insurance systems, where software evaluates claims, but humans still need to make the final decision. Financial systems, where automated models flag risks, but accountability still matters. Even industrial settings, where machines produce streams of telemetry and someone has to decide when something important has actually changed. All of those situations have a similar shape: messy signals, interpretation, and then a decision about what happens next. That's exactly the kind of structure an emergent state machine is designed to handle. So, right now, I'm exploring the question of how far that pattern might go. And one way to explore that question is simply to let people experiment with the system itself. So, I put the project online and started sharing the work: the code, the papers, the diagrams, the whole thing. You absolutely do not need to be a programmer to engage with it. I think I proved that with Mobs' help. If you're curious, you can go visit the Digital Learning Companion in the Open Core repository. The Digital Learning Companion is really just a starting point. You could build a tutor for another math topic, a practice writing tool, a training simulation, or something none of us have thought of yet. Part of the goal is simply to see what kinds of systems emerge when people begin experimenting with the architecture. So if you have an idea, try it. I can't wait to see what you build. And in the meantime, I am open to hearing your comments, questions, and concerns. Thank you.